All right, this video is going to go over 13.2, 13.3b, which is exponential growth and decay. So let's go ahead and get started. The first thing you need to know is in terms of exponential growth and exponential decay, generally you're going to be looking at this b value. All right, so if it's greater than 1, say you had something like 5 times 2 to the x. If it's greater than 1, it's growth. Things are getting bigger over time. Whereas if it was less than 1, like say you got like 0.72 or something, that's going to be decay. So you're looking at the number with the exponent really in terms of figuring out if it's growth or decay. So looking at this right here, the first one would be growth because it's a 3. The third one would be growth because it's a 4. And this one down here would be growth because it's 1.15. It's more than 1. And then this one would be growth because 5/3 is greater than 1. That's like 1.67. Now all these others, like 0.8 would be decay. 1/2 would be decay. 2/3 would be decay. And 0.595 would be decay. So that's pretty easy so far. Now, what you're going to have to do is you're going to have to use this equation, y equals a times b to the x. And really this right here, it's going to be 1 minus your rate, or it could be 1 plus your rate, I guess. So 1 plus minus rate. I'll show you what I mean by that. And then the one more really important thing you need to know is like percentages. You need to divide by 100. So like if it said 8%, you would put 0.08 as your rate. Okay, hope that makes sense. So like look at this first one. A tree 3 feet tall grows 8% every year. How tall will it be after 14 years? All right, well, it's growing, so it's growth. And so you use this equation, a times b to the x. A is your starting amount, so it started 3 feet tall. So y equals 3 times. Now, the tricky part is the rate. It says 8% per year, and it's growing. So what you do is first you got to get 8% to a decimal. That's 0.08. You just divide by 100. And so it's like 1 plus 0.08 is what is going to go there as your b value, 1.08. And then x is just time. So they say 14 years. So that's your x. And so when you punch this in, 3 times 1.08 to the power of 14, you get 8.81. So that would be my answer, 8.81 feet. So since it was growth, we added that rate to 1. All right, well, this next one is it says worth 6% less each year. So this is gonna be decay. Now it uses the same equation, a times b, let me get rid of that, a times b to the x, okay? Where a is your starting amount, so purchased for 9,000, that's your start. Now the tricky part is the b. B is 1 plus or minus the rate. Well, they say 6% less. So 6% is 0.06. All right, so it's like 1 plus or minus 0.06. Well, since it's decay, it's going to be 1 minus 0.06, which is 0.94. That's going to be your b value. And then in terms of time, it says 5 years, so it's to the power of 5. So when you punch this in, 9,000 times 0.94 to the power of 5, you get 6605.0 14. That's dollars. So the key is the blue part, being able to get that B value correct. It's 1 plus or minus your rate. All right, look at this last one. You're still going to use A times B to the X. All right, but the difference here is they're asking for the original value of the machine. That's your start value. All right, so what they give you is the machine is now worth $7,500. That's your final price. You're looking for the start value. Your B value, it says decay factor of 0.75. So you're just going to throw a 0.75 there. And then it says after 6 years. So that's your time. And so 0.75 to the power of 6, you get 7,500 equals 0.178-ish, 0.178 times A. So to solve this, you just divide by 0.178. And that's actually rounded. I'm doing it without the rounding on my calculator. So the value I get is 42,139.92. So that's how you would do that one. It's kind of a backwards one. All right, and then the last thing, I threw this back on here. This is part of the homework, but you got to remember how to graph these things. So remember growth, decay, and reflections. Take growth and flip it. This one would flip across the x-axis, so it'd look like this. So let's see here. The first thing I do is I figure out what the shape looks like. This got reflected across the x-axis, so it's going to look like red, not the top one. Looks like this. All right, next I find out my my horizontal asymptote, which is y equals 1. It's here. All right, and now I find out my y-intercept by plugging in 0 for x. So if you plug in a 0 there, you get -3 or negative parentheses 3 squared plus 1. So it's negative times 9. So it's -9 plus 1, which is -8. So that's down here. And now I just got to make it look, take the shape. It's going to hit about -2, I think. Looks like that. So your domain, it goes left forever, right forever. So it's all reals. And your range, the lowest it goes is -infinity. The highest it can go is that asymptote at 1, but it can't hit it. All right. This next one is exponential decay. So the graph of exponential decay, instead of it going up like this, it starts high and goes low like this until it hits the asymptote. So this is the shape it's going to take. Next, I find my horizontal asymptote. That's at my shift of 2. All right, and now I just got to find my y-intercept, which if you plug in 0 for x here, you get 1/4 to the 0 plus 2. Well, 1/4 to the 0 is 1. So your y-intercept is 3. So now you just make it take the shape. It would look like this. Your domain, it goes left forever, right forever, so all reals. Your range, the lowest it can go is that 2, the asymptote. The highest it goes is up forever to infinity. So that's how you do that. These aren't too hard to solve as long as you can get this rate part correctly. That's critical. So hope this video helped.